Okay.
And then I also heard that our phones use network interface cards.
Okay. They have
And then
network
for the
interface cards
types,
that are able to connect to wireless medium. Yes.
yes, please. And the types we have WLAN, which is wireless local area network,
Yeah.
and wireless personal area network,
Great.
and wireless wide area network.
Wonderful. Right. So these few things that these individuals have explained, there is no way they will ever forget, you know. Sometimes when you learn something, you try to also teach someone. So as you keep doing that, you become better at it. So when I ask questions, don't worry. At this point, you know yourselves. So there isn't anything like somebody is going to be teased or whatever. Let's feel free and let's have a good dialogue, especially when we have lectures together. Right. So the ladies have been able to redeem all ladies in here, with the exception of Emanuela Dede. She hid. And then for that, I'll subtract 2. I'll make sure she doesn't get full marks for attendance, unless she redeems herself in the next model. Right. So Emmanuel gets ready. When it's question time, you're going to tell us what you've learned in this module before the guys do come in. So quickly, let's move on to the second module. So here, our concentration is going to be on how wireless local area networks, how they work, and how IP networking is. So, of course, this is for undergraduate students. So I'll move straight to the focus for the module. So with this module, for module 1, we learned we learned some few things about the wireless network. And in this model, our concentration will be on the actual functionality of the wireless local area, some of the things that goes on in there, the functions internally that goes on in the wireless space. So that is what this module is meant to do. So you can see how WLANs work and IP networking. So those are the things that we're talking about now. Now, what happens when we connect to a Wi-Fi? Any Wi-Fi. In the moment we connect to a Wi-Fi, what really happens? There are in fact, there are 4 main things operations that goes on when we connect to a Wi-Fi. Let me bring out my laser. And these are what has been outlined here. So when you connect your laptop or a smartphone to a Wi-Fi network, it may look like it's something so simple in actual fact, but it's not. Behind the scene, physically, all we do is we click on wireless and we connect to the wireless, and click on a wireless name SSID, and we enter the password depending on how the wireless has been configured. And that is it. We think it's so simple. But behind the scene, there are a series of coordinated technical processes that actually take place within the fastest possible time, in milliseconds. So you connect, enter your password, bam, you're online, you're connected. So these processes are the ones that ensure that your device can communicate securely and also correctly within the network where you're going to acquire internet access. So let's walk through each one of them. So firstly, this is what happens. We have the device discovery network. I'll talk about each one of them. But this is just to introduce to you that there are 4 key things or operations that happens whenever we connect to the Wi-Fi. First of all, we have the device discovery. Our device will discover a network. Once it does that, it authenticates itself on that network. And if the authentication is correct, then an IP is given to the device. And finally, we are able to send data across different protocols from the sender and also to the recipient. So these are the 4 key operations or steps that we go through anytime we connect to our wireless. Now, in understanding these processes, it's very important. It's so critical in the area of cybersecurity. Why? The fact that you understand this means the hackers or the adversaries also understand this, and they are going to use their knowledge in this to exploit you when you are using the wireless medium. So understanding these 4 processes are critical for cybersecurity, mainly because every stage of the Wi-Fi connection also has its potential risks, attack surface that the attackers can use to exploit. So in this case, you can see that the attackers do not wait until the data is flowing. They can exploit the weakness from the very moment a device gets connected onto a network. They are smart enough. They understand these things. So we are going to go in depth and understand what goes on in there in these 4 areas in terms during the discovery of the network, the authentication, and also acquiring IPs. Now, when we pick the first one, which is the network discovery phase, what the attacker can do is he can set up a rogue access point. Sometimes we call it as the evil twin. Sometimes too, we can also consider it as a man in the middle. And what it does is to imitate a legitimate Wi-Fi frame or Wi-Fi name that is available. So you see a wireless connection, you get connected to it, you think you've connected to the right wireless. Meanwhile, the attacker has just set up a rogue network. You get connected to it, you pass through his connection to the internet. So every packet that is being sent is able to sniff this packet and also use it to do whatever. So in such situations, if you are working with on unsecured data platform, you can imagine the kind of things the attacker will be able to gather from you connecting to his network. So if a user device connects automatically, the attacker can intercept and manipulate the traffic before the user can even realize something of that sort has happened. Phishing can also be routed through this approach. And most times when you talk of phishing, the concentration is on emails being sent to you that look like legitimate sites and so on. Now that is about the discovery phase. So what happens at the authentication stage? So if the wireless device has weak password or it has an outdated encryption protocol, like those of you who have been using a protocol like WEP, that is the wireless equivalent privacy. It's the simplest way of hacking or getting the password of an access point or a router. That's the simplest way to do that. My master's was in this area, so I worked with I think that time I worked on the network, UMass network, and I was surprised to see that majority of the wireless devices, and even now, I'm not so sure if the ICT people have updated some of these records. There were some access points, there were Cisco routers that were configured with WEPs. I was very surprised, and it was easy to hack them. Within a split of a second, you have access to them. Then those that also use the WPA, that is the first version, WPA came mainly to mitigate that little issue, the legacy issue with the wireless equivalent privacy. So it wasn't strong enough. Eventually, hackers also found a loophole in that. Then WPA2 came in. I think currently there's a way of bypassing some of these things. Yes, so a lot of things go on in there. So if the authentication is weak, then it's easy for people to, to get your packets, analyze it, and also steal some frames from you. Now, most of the broadcast that is happening on our phones, we normally use WPA2, PSK, that is a pre-shared key. So the PSK, as you are aware, is just a personal shared key. So it's just one key that you give to different people. So if somebody is on the same network as you using the same PSK, there's a high probability the person can also steal other people's information that are also on the same network using the same PSK. So in mitigating that, you go a step further with the WPA2 enterprise. The enterprise has got to do with individual access to individual people on the network. So by going the enterprise, that is where you bring in something we call like radius authentication free radius, individual login details. Where every individual who is going to get connected onto the internet will have some kind of authentication routes that they will use to get into the network. So the enterprise way was the best route to secure most of these wireless security standards that we put up. So the authentication state, think of it like have very strong passwords, make sure your encryption protocols are quite high. You make sure you configure your servers properly. If you need to patch the servers or even the firmware of the access points, you patch them. These are ways hackers are able to get into your network. Sometimes they can brute force attempts by trying so many times, by using different tools to get access to your networks. And again, at the IP address, that is where this particular point, when I get an IP address, where the IP is being given to you, either by the router or by a server somewhere that has DHCP also installed. So in that case, if there is a server that is giving out DHCP, what the attacker can do is to exploit the weakness in that particular DHCP. I'll talk about what DHCP is, Dynamic Host Configuration Protocol, but I'll explain it into details as we move on. So in some situations, the DHCP starvation attack is deployed, and it does so by, when that is done by the adversary, it will redirect most of the users to the malicious gateway, thereby, disrupting the kind of network availability to such individuals that are on that particular network. Now, the final one, which is the data transmission, at the points where you have an IP, you are uniquely on the network, how do you get connected to the data, how are you able to send data from one point to the other? If the attacker understands these four processes too, they will go a step further to target the kind of protocol layer that you are using to send traffic. So they have a technique like the packet sniffing. That is a tool that you'll be using. You'll be using Wireshark and all. I know majority of you have had some practicality in this area, but for these purposes, you go through this again. Managing of the middle attack, session hijacking, DNS spoofing, all those allows these adversaries to steal data and also alter some of the communication data or information that is being transmitted across the medium. Now, there are key things that you should know that I might have to, emphasize on. Most of these important, most of these four things that I've talked about, the attacker has knowledge of them. So you have to be careful, understand it. And once you have knowledge of these things, you are able to protect them, you secure your systems properly. And at the end of the day, you wouldn't have the adversary having advantage over you. Now let's talk about the first section in this area, which is the IEEE 802.11 standards. So this is the well-defined standard for Wi-Fi connections that we'll be using. So this 802.11, this one, 802.11 standard, it defines the kind of rules that allow wireless devices to communicate over the Wi-Fi or the wireless fidelity. So this is a standard, and it helps most of these wireless devices to be able to, communicate with other wireless devices. So each of these standards, as you progress, you realize that each standard improves with speed, range, efficiency, and also security. So I'm going to talk about some few of these as we move along. And the earliest standard, if you recall, in the first lecture, I spoke about the 802.11 A, B, and G as being the obsolete ones. But of course, there are some devices that are still broadcasting using these standards. So we can't do away with them. So the earliest standards were the ones that we termed as 802.11 A, B, and G. And their concentration was mainly to focus on the wireless connectivity. But the new ones that exist, that is the N, AC, and the AX, they rather support high data rates and multiple devices. So because of that, they're able to give us better performance in an area where, in an area that is so crowded, like a campus, if you have so many people in a classroom, for instance, the best standards to use will be the ones like the N, the AC, and also the AX, sorry. So it is very important to understand these standards. When you do, this particular standards and where each of them fall. A, B, and G are the old ones. Now, those were the earlier standards. And I'm saying the new ones are the N, AC, and AX. So once you understand the standards, it will help you in selecting the approach to secure and get high performance wireless local area networks, Right. So let's pick these. So 802.11. So as I said, these are international standards, and it was developed by, as the name says, IEEE, the Institute of Electrical and Electronics Engineers, IEEE. And this standard defines how wireless local area network should operate. And all the wireless local area network that you see on campus or wherever in your homes, they operate behind this particular standard. That was developed by the Institute of Electrical and Electronics Engineers. So now these standards, they ensure that the devices from different manufacturers can communicate reliably over the Wi-Fi, over the wireless Wi-Fi or wireless medium. So for instance, some would have Cisco products, Cisco access points. Others will also have trend nets. Others will have, I think, but there are a lot of products. There is one in my office, which is there's Linksys, which is a variant of Cisco. Those that have used Packet Tracer before, you realize that Linksys is one of you'll see Linksys router in a simulation environment if you use Packet Tracer. So these standards were developed mainly to make these manufacturers of these wireless devices to stick to a specific standard when they are broadcasting signals or they are broadcasting signals where people will be able to connect wirelessly. Without that, you will not be able to maybe use a Cisco product and Ubiquiti products, they will not work, but once this standard is there, when the manufacturers are, producing such devices, they will stick with the standards. And irrespective of the manufacturer, most of these devices most of the time are able to talk to each other. So the standards specify several key aspects of the wireless communication. And the first one that you see here is a frequency band. Then we have the data rates, the modulation technique, and also the security capabilities. So these are the specific key aspects of the wireless communication when it comes to the standards that is being produced by the IEEE. When you pick the first one, for instance, like the frequency bands, IEEE 802.11 itself, they define which of the radio frequencies the Wi-Fi can use in terms of the frequency band. And most of the frequencies that the wireless is able to use is the 2.4 gigahertz, 5 gigahertz, and the 6 gigahertz. These are frequency bands that have been standardized by the IEEE organization. So when these manufacturers are producing these wireless devices, they stick to these frequency bands. And the bands are the 2.4, the 5 gigahertz, and the 6 gigahertz bands. So these bands, of course, they are affected by range. interference and also performance. So the 2.4, they are able to go further away. So if you set up a wireless, a WLAN, for instance, using access point or router, whichever it is, when it is running on 2.4 gigahertz, it's able to go a little further than when you are running 2.5 gigahertz. 5 gigahertz, the range is quite limited compared to that of the 2.4. When we move to the next slide, you will have a detail of each one of these ranges, interference, and also the performance of the frequency bands. For the data rates, each of the IEEE versions specify the maximum speed at which the data can be transmitted. So currently, the newer standards support high speeds to handle modern applications like video streaming and also online learning. So the new Wi-Fi devices that are being produced, in terms of the data rates, IEEE versions have made it possible for them to give out a maximum speed. And the new ones have higher speeds. And because of the higher speeds, they are able to handle applications that consume so much data, like video streaming and also online learning, like what is happening between us. For the modulation techniques, the standard also defines how the digital data is converted into radio signals. We have it over here. You can see how the signals are being encoded. So the standards in this case is able to define how the digital data that we have is converted into radio signals for transmission. So most times, the more advanced modulation allows more data to send in the same amount of time, and it does so by improving efficiency. When you look at the security capabilities for this one, of course, older versions would have weak security. So the IEEE 802.11 again is able to include some sort of mechanism for securing most of the wireless communications over here. And in this case, the authentication that is being embedded in some of these devices have high specification encryptions. And it does so to protect the user from unauthorized access, maybe unauthorized the users from people who are not supposed to have legitimate access to the system because of the high encryptions that are being put on these. So for the 802.11, these are the four main things that defines how the Wi-Fi communication should work. The frequency bands, the data rates, the modulation techniques in terms of the encoding, and finally the security capabilities, high specs, encryptions, and also protection methods that are being used. So in overall, the 802, IEEE 802.11 acts as a technical foundation for wireless fidelity, which is Wi-Fi. And it does so by setting up some rules that make wireless connection fast, compatible, and also secured across our homes, campuses, and also public networks. Right. These were the common things that I was talking about. Like each one of them also have their limitations. So these are the standards that exist, and these are the frequency bands of which they were operating, and the speed, and also finally the common name that we term them. So for 802.11a, A, B, and G, those are the old ones. So the A had a frequency the frequency for transmission was 5 gigahertz, and the maximum speed was 54 megabits per second. Of course, the common names, they are all Wi-Fi with the different numbers attached to it. So here, for the B, it was able to transmit data through a frequency of 2.4 gigahertz, and the maximum data speed was 11. So for instance, if you have so many people connecting to 802.11 router, for instance, or access points, and the maximum throughput is 11 megabits per second. So if you have about 22 people connected, on the average, what do you think is going to be the speed of each individual? All things being equal, if no one is streaming and they are all using the internet equally, what do you think is going to be the maximum throughput speed in terms of speed of people who are connected to 802.11b? 22 students. Anyone? Hello? Hello? Watch it. You care to explain? Or the question again? What I'm saying is the standard 802.11b. In fact, these are basic things that you should know. So let me explain it again. The standard 802.11b, the frequency through which it transmits data is 2.4 gigahertz. And the maximum speed this particular wireless fidelity can go is 11 megabits per second. So if there are 22 students on this particular Wi-Fi fidelity, on the average, what is the maximum speed each student would have when they are connected to such a wireless access point? Rosalind says 1 megabits per second. Shadrach says 0.5 megabit per second. Okay. 1 megabit. Okata. Hi, Okata. You. I remember the name, so you're laughing. Yeah. Yes, so 1 megabit per second, 0.05. So we have two different 0.5. Great. All right, so if it is 0.05, that is about 500 kilobits per second. Is that kilobits? No, 500, 0.5. All right, let's still stay with the megabits. So in actual fact, it's going to be 0.5 megabits per second. So you can imagine, the more people get connected to a wireless network, the slower the speed. So if the maximum throughput for a wireless device is 11 megabits per second, then you can imagine that the cables are going to be better. That's why we always say the cable connection is the fastest in terms of speed. Wireless is not the best. But if it is in your house and it's okay, you are the only one using it or few people using it, you will not experience the latency. See how I use the term? You will not experience the latency when you get connected to these devices. Right. Now, when we move on to the G, it's also what's going through the 2.4, and the range, the maximum was 54. The N is able to broadcast 2.4 and also 5G, and the maximum speed was 600 megabits per second. These are wireless devices. So when you are buying a wireless router or access points, think about these. If not, you'll be disadvantaged. You just go and buy any wireless router and you think it's going to be very fast. No, it will not be fast. You have to know which one you are buying. Of course, as you move from top to bottom, the prices also increases. And again, we have the AC, which is 5 gigahertz, and the speed is 1+ gigabits per second. And finally, the AX, and this is the frequency bands that you see, and that is 10 gigabits per second. So you can see the kind of speeds that this particular Wi-Fi fidelity will be able to exhibit. Right, so the ACs, they operate exclusively on the 5 gigahertz, and they are able to deliver gigabits level speed. And is optimized for high bandwidth applications like HD video streaming and large files transfer and so on. So for a takeaway from this particular slide, always remember that each new Wi-Fi fidelity or wireless fidelity standards improves in speed, efficiency, and user capacity. And it does so by making the modern wireless network faster, more secured, while supporting many devices at the same time. So don't just buy any wireless router or access points. Know the type that you are buying. Know the kind of people you are going to serve these wireless devices with. All right, so with all these said, now let's go to the next slide with an explanation of an example. So this slide, for instance, compares different generation of Wi-Fi standards and explain why newer standards perform better in real world for this particular slide. So if you look at the 802.11b and G, they are the oldest and they are slower. And these standards are among the earliest widely used Wi-Fi or wireless fidelity technology. They were operating somewhere in the frequency of 2.4 gigahertz band, which is quite heavy. And they are heavily congested. So you can't have so many people coming in with such a platform because the speed itself is not quite big. So it becomes congested. And the reason is many Bluetooth device, cordless phones, microwave ovens, they all use the 2.5 gigahertz standard. Microwave, it uses the 2.5 gigahertz band. So because of that, this particular standard will suffer high interference. If your microwave is working and you are transmitting data, if you are closer to it, you can imagine the latency that could fall in there. Although these wireless devices have some sort of convergence, you might experience certain latency or delay in transfer of data, leading to the network being slower in speed and also unstable. It is obvious that we have a large amount of outdated Wi-Fi fidelities around. We can still find them in most of the legacy devices and old routers. On campus, for instance, you'll be surprised to see very, very old routers or access points, configured wrongly. I'm sure some of you have seen some of these things. Yeah. Yes. So for the N, it's an improved speed. It comes with an improved speed. Obviously, these ones improve the wireless fidelity performance. And of course, it does also operate with a 2.4 gigahertz, and sometimes you see it as 5 gigahertz bands. And with these ones, the good thing is it reduces the congestion that we see in the B and the G. And it does so by improving how reliable the network is. The key feature here is most of the 802.11n is MIMO. When I say MIMO, that is what is here. It uses MIMO. So there's multiple inputs and multiple outputs. And because of this, they are able to allow multiple antennas to transmit and also receive data simultaneously. Some of these routers, each of these antennas are able to have these multiple input and outputs. And data is being transmitted, simultaneously from different antennas. So this is significant. Of this particular standard, you see that it is, in terms of speed, it is quite high compared to that one, the first one. And in terms of reliability or stability, this is better. All right. But the good thing is most of this particular type of standard, we will see it in campuses and in our homes. But of course, you will see some of these old, obsolete, or late legacy devices. You will see some of them also in homes and also institutions. So with this knowledge, if you get the opportunity, please get a better wireless signal and wireless devices so that you get protected properly. The AC obviously is very fast, better for many users at once. It is used in modern routers and also enterprise Wi-Fi. So obviously this is better than the others. Now, with all these knowledge, please don't go yes. If you can give me some time, let's close at 8, please, so I can finish this one. I'll finish very soon. With this knowledge, what do you think will be the answer for this particular question? A lecture hall with 200 students needs which type of standard? A lecture hall with 200 students, and the students are using laptops together with their phones connected to the wireless at the same time. So if all students there are 200 students there, they are all using their laptops connected to the wireless, and they are all using their phones connected to the wireless. So we have about 400 nodes on the network. So in a situation like that, which of the standards would you recommend? Leonard says AC and AX. Any other? All right. Gertrude also says AC and AX. That's in actual fact, yes. Why? Mainly because when you use the B's and the G's in such an environment, we will get the results of the network to be very slow. Connections will be dropped. The users will not really have a better experience. But when we connect it to the AC and the AX, it has a higher speed. It is more reliable. So there wouldn't be any congestion on the network. So in actual fact, Leonard and Abuga, you're all right. So the key takeaway here is as the number of the users and devices increase, always think through. When you have so many people coming onto the Wi-Fi, you should know that the old Wi-Fi fidelity standards, they become inadequate. And because of that, we have to switch to the new IEEE 802.11 standards, which are the ACs and the AX, especially when we are thinking of places where we have huge capacity of people coming in there, like campus, some environments that a lot of people converge. So let's be mindful of that. So security is very important. I spoke about the old standards, its limitations. So for the legacy wireless standards, typically they rely on old and weak encryptions. And because the encryptions are weak, and most times you see the EP, WEP, that's the wired equivalent privacy, and the WPA, being used. So we have to find a way to protect them. So old standards are not really the best. So security-wise, we need to update such systems with new ones. Then the modern standards, most of the modern standards support these better encryptions, the WPA and PA3. But of course, if you are using it as a PSK, it's not so bad. It is okay to protect you. But when you transcend it to the enterprise environment, that is where each individual user have access to the WPA encryption. So you log in, you are not using a pre-shared key, a personal shared key. We are all using different login access through this protocol. Then that is quite better. It has better protection against interference and also attacks. Now, section 2, wireless association and also authentication. So with this, remember I talked about what happens when we get connected onto the Wi-Fi. So these are the processes that we go through when you connect to the wireless router or access points. So first of all, at the discovery phase, when you connect your laptop or smartphone to the Wi-Fi network, what it does is it tries to look for some connection like the SSID, that the discovery phase. Most times we think this is quite simple, but behind the scene, a lot of things are really happening, as I said earlier. So we can have a series of these coordinated technical processes come into play. So for the first one, let's pick the discovery and talk about what happens. That is the first phase, the discovery phase. This particular phase, what happens is, we first of all, the device does a search for the available wireless networks that are around. That is the discovery phase. The Wi-Fi access point or the router that is possible, that is available, will continuously broadcast signals called beacon frames. So the access point that you see on the walls, every time it is broadcasting signals, and that signals, we call it beacon frame. The beacon frame. That is a continuous broadcasting of such signals from the Wi-Fi fidelity or access point or router. That is called the beacon frames. So these frames contain important information. And within that information, you will see the network name, which is the SSID. You see the supported Wi-Fi standard, which is the IEEE 802.11 standard, be it NAX or XE. And in the same beacon, you will see the security compatibility. It could be WPA or WPA2. You will also WPA2 or WPA3. I'm talking about the current secured ones. So what your device will do is it will listen. Your device will listen for these signals inside the beacon frame and display the available network on your screen. So if I pop up and try to see this available wireless that's available in my domain, I just put on my wireless, then the beacon frame already continuously is being broadcasted. So I'll see all these things. The first thing that I'll see is the SSID. So when you make a selection of one of the SSID, your device sends something we call the probe request. So the access point or router will give you a beacon frame with all these information, the SSID, the Wi-Fi standard, security type. Then your device will send a probe request to the specific access point that you choose among the list. So once it does so, then it's just like saying, I want to join your network. So when you select it, you send a probe request by selecting it. So at this stage, what happens is you will not have internet access. It will not exist at this point. You only send a probe request, and your device is only identifying and locating a network. That is a probe request. That's what happens. At the authentication phase, this is what happens. Now let's pick it one by one. So once the network is selected, in our case, the next step is to authenticate. So at the authentication stage, if the wireless beacon is being broadcasted broadcasted with open credential. By open, I mean there is no password attached to it. Then it means you can just connect to it and you have access to it. But if you have to authenticate, this is where you have to prove the identity of the network. So in doing so, you have to enter the either the login details or the PS key of that particular Wi-Fi. That is a pressure key of that particular of that particular Wi-Fi to get access to it. So in our homes and the campus Wi-Fi, this is often done using a password. I'm sure you've been seeing UMAT wireless, and the password is, I think, 1 through to 8 or so. And depending on the type of authentication and the type of security that is there, whether PS2, PA2, PA3, PSK, you enter it and you get access to it. In an enterprise environment like the university network, some years back, you just can't join the university network. You would have to go through, you have to enter your username and a password by something we call a captive portal. Unfortunately, for the past, I think about 10 years now, there hasn't been any integration of these login details. And you see people coming from Campanasi and people who are not students having access to our internet. This is one thing I have spoken to the ICT. I don't know why it still has not been resolved. It is security-wise, it is bad. You are cybersecurity guys. So you can imagine people, anybody connecting to our network and having access to people's information and all, you know, maybe looking at, based on the labs and the information you give, I probably might have to speak to the head of ICT again, because this is totally bad. You can't have people who are not legitimate on campus to be having access to our system. Right. So in an enterprise environment like the university, it is best to use a username and a password. And that is where we don't use PSK, but we use maybe WPA2 or 3 enterprise mode. So we will not have a preset key where all of us will use the same thing. But however, every individual student will have their login details to access the network, and that is more secure. So that is how the authentication phase, either PSK or enterprise, that could be done. And during this phase, the access points verifies that your device is allowed to connect. The encryption key are generated to protect your data for eavesdropping. So you see what I said. The encryption keys are generated to protect your data from eavesdropping. Imagine if all of us are using PSK, the same PSK. It is not uniquely tailored to an individual. So you can imagine what can happen. But for an enterprise environment, you have your login details, your encryption keys are solely to you, and they are generated solely to you, and it helps prevent eavesdropping. And finally, right now, the way it is, it looks like even if you use a PSK, then it means you trust the person having access to your network. If we are all using the same PSK and there's an adversary or a very good black hacker amongst us, you can imagine what they can do. And usually, if the authentication fails, the device is denied access. If it doesn't, you just gain access to the system. So for the enterprise authentication, this is actually the best route. You have the 802.1x. So that is where we normally use this one, the radius for authentication. Then we talk about the association phase. This is very important. At this particular, in fact, I'm recording all these. So when I'm done, I'll put it on the VLA page. So you see it somewhere here. You are not going to miss anything. You see it somewhere at the bottom here. You see module 1, I'll put the video there. Module 2, I'll put the video there too. So you can always come back again to it. So you will not lose anything. All right. Well, if I realize you don't come to class as you should, then I'll stop putting on the video. Right, so let's move on. So that is the associating phase. This is very critical. And sometimes we can say this is the point where IP addresses are given to the computers that get connected to the access points. So after a successful authentication, your device still cannot communicate on the network until it has been given an IP address. And you and I know that the IP address is what uniquely identifies everybody on the network. So once you get an IP address, you become a legitimate node on the network. So without getting an IP address, you are not on the network. The moment you get it, you're on a network, and you are now called a node. So IP address distribution is one key thing that you need to get. And how do you get that? This is where the DHCP comes in. So on your phones, I said it has a mini DHCP that gives out IP addresses. So when you put on your hotspots, anybody who connects to your hotspot, an IP address is given to that individual. So such individuals, all those people that have access to the hotspots, now we say they are uniquely going to be identified on the network. So that is the IP address. And this is done by a protocol or a system, what we call DHCP, Dynamic Host Configuration Protocol. So it comes in to give you an IP and it goes. So you connect to a wireless access point. You send, the beacon is there from the access points. A probe request is sent by the computer. Then an authentication is being sent for you to complete. When you complete it and it is correct, then an IP is sent from the router or the DHCP server to you. And the moment you get an IP, then you are now on the network and you are now unique on the network. And at that point, you would, I'm saying that at that point, you'll be given an IP, you'll be given a subnet and a default gateway. If you have to go to the internet, and a DNS would also be given to you. So this particular side is very important. So please, the associative phase, always try and understand. You can also think of this particular step as giving a device a house number or a postal address, just like your index number or reference number. It is uniquely identifying you as a student of UMass. So if you connect to my network, then it means I have to uniquely identify you on the network so I can talk to you at any point in time. That is when a DHCP server comes in. Once you have a DHCP server, you will not have IP conflicts coming in and out. Now, without this, data would have nowhere to go and nowhere to return. So you don't have an address. If I post something to you, where do I take it to? No, I wouldn't be able to know where you are. So there's no way you'll be able to receive what I want to take. Now, all these things happen in a millisecond. So you will not even see that a lot of things go in technically. And finally, let's talk about the data transfer phase. Guys, those that are here, I'm happy you are here. Just bear with me. We've missed 2 lectures, so let's complete lecture 2 and to go. Oh, that's quite a number. Right. So we finish very soon. Just by 8 o'clock, we'll be done. Hopefully. Right. So the data transfer phase. So once you have the IP, your device is now fully connected and you are ready to communicate. And when you open the browser, you're able to talk to you're able to browse, send emails, and so on and so forth. And these are the active communications, the encrypted traffic, the IP address essentials, all these, you go through that. So most of the time, the data travels through multiple protocols, and the protocols I asked about the TCP/IP, physical data link, network, transport, and also application layer. These ones, they form the basis of data communication. So I'm sure you've been taught. So be mindful that the next time you connect to a Wi-Fi and it just works, remember that there are a series of phases that it has to go through. First of all, finds the network. It proves that it's allowed to join the network. It's being assigned on the network identification, which is the IP address, and it begins exchanging data to multiple protocols. Irrespective of the protocols, you can send data and be doing things. So when you understand this process as a foundation of studying wireless networking, cybersecurity, and most of the time, mobile communication systems become so easy. So this is very paramount, so important. You need to understand them. So in terms of security notes, if the adversary knows all these things, you can imagine they will be able to set up this rogue network as I talked about, capture the authentication handshakes and false authentication attacks on you and do all these things. So these adversaries, they understand these things. Now, let's move on to section 3, which is IP addressing in wireless local area network. All right, guys, should we continue or you are tired? Should we continue?
Yes, sir. Yes, sir.
Let's continue. We love
Yes, sir.
you.
Yes, sir. Yes, sir.
Okay.
So I'm in love with the cheating. Please
More fire,
continue
more
for
fire.
us.
Hi, you people can give fake fans. All right, so let's continue. We'll finish very soon.
Thank you, sir. We are interested. We love you, sir.
Let's quickly. So let me continue. And mind you, I'll break the video into two, like the first module and the second module, so you can revisit it and complete the labs. Right, so let's talk about IP addressing here. Now, in this particular session, in section 3, when you connect to a Wi-Fi alone, it doesn't mean that the device can communicate on the network. No, you have to get some sort of association with the network. And that is when the IP address comes into play. So meaning if you don't have an IP address, your device can't send or receive data because it has no address, no location. So we need to make sure we have an IP address running behind the scene for us. Now let me pick the first slide on the session 3. Now, what is an IP address? You guys know, it's a recap for you. It's easily said, we say it is Internet Protocol. And it's a unique number that is given to any computer that is connected to it. So in our case, if you look at this one, this is a unique numerical identity of that is given to a computer, 192.168.1.25. So without an IP address, a device cannot send data, cannot receive data, neither can it access the internet. So IP address is very key. Now, how do you get the IP address? I've spoken about it. That is where DHCP comes into play, Dynamic Host Configuration Protocol. So in itself, it's a network service that is automatically able to assign IP addresses to any device that legitimately connects to the network. So there are a series of steps, and we call it the DORA process. The DORA process: discover, offer, request, and acknowledge. The DORA process is a series of steps or processes that we go through to be able to assign IP addresses to devices. So the first of its kind, which is the discover stage, this is where the devices send a discovered message. And it does so by broadcasting a request to find an available DHCP server. So in your router's case, you connect to the router, a discover is sent to it, to the router, to see if there is a DHCP there. And the router has an inbuilt, more or less, DHCP system. So it gives an IP address to you. So if you are using an access point, for instance, it doesn't give you an IP address. It connects you to the switch. And the moment it does that, you connect to the access points, the device will send a discovered message through the access points, broadcasting a request to find any available DHCP server on the network. And when it does find a DHCP server on the network, the message here is that, is there any DHCP server that can give me an IP address? If there is, then we move on to the next step. The DHCP server can now respond with an offer. And it does so by proposing an available IP address along with the settings such as the subnets and also the default gateway. These are very key. When you have these three things coming in for you, DNS is also one important thing, then you are at the verge of getting connected onto the internet. So the next step after this is that the device will then send a request message, this time around indicating that it wants to accept the IP that is being offered by the DHCP server. And finally, the server completes the process by acknowledging that indeed, because you've confirmed that you want the IP, the server now acknowledges it and give you the IP. Now, DHCP is very important in networking. Why is that so? Imagine 200 students, as I said, in a class, all trying to connect to an AC or AX Wi-Fi. When they connect to it, behind the scene, there dynamic host configuration protocol device. That is all it does is to give out IPs. So it will give, we connect to it, it gives you an IP. So all 200 people with their phones making 400, we'll have all of them getting an IP within the split of a second. But if we were to go, if the DHCP is not there, then it means we have to manually configure the computer. Manually configure the configuration. Sir, please, a computer requesting for an IP can reject one provided by the DHCP. Wachi, if you can unmute yourself, I think I would want to understand what you mean. Some years back when I came to UMass, every lecturer has their own IP address. So, and there was a book that we were given, we're writing IP addresses of lecturers, professors, and associate professors. We write it down. Maybe Dr. Aye, your IP is 192.168, and it's in a book. So it means we were manually giving IP addresses to every lecturer. So imagine somebody coming onto the network and now manually typing the IP address of maybe Dr. Aye. It will cause a conflict. That person will not be able to browse. Dr. Aye will also not be able to browse. So you can imagine what happens. So because of DHCP, manually configuration of IP addresses in people's computer is now not important. That is how come we are going through this route. So DHCP is very important. Wachi, if you can raise your hand, I'll give you access to unmute yourself so you can ask your question properly. All right. But usually, once it does that, an IP is given to you, the computer accepts it and uses the IP address. Can a computer reject a requested IP address which is provided by the... No, it will not reject it. It needs it. That is why it requests for it. So once it does the request, automatically it is sent to the person. And even that, we have something we call DHCP lease. So if it gives you the IP address, if the network administrator configure the DHCP lease to be, let's say 3 hours. So it means they are loaning you the IP address for 3 hours. So after 3 hours, you have to request for. You'll be locked out. You will not have access. So after 3 hours, you have to talk to the server again, the DHCP server again, to give you an IP address again. Why is that? Why do we put up leases on IP addresses? We do this because sometimes, for instance, in School of Petroleum, a student comes here, he connects to a Wi-Fi. Within 2 hours, he doesn't have a lecture again, and he goes. If the total lease of IPs to be given here is, let's say, 200, the student has picked an IP, he has taken it away. It's not in the network, but the DHCP server has registered it. So if somebody comes in again and is trying to connect to the wireless, and the entire IPs that is supposed to give is depleted, the person can't get access to the network. So that is the importance of putting lease time on IP addresses. So that if the person moves away within 2 hours or whatever, the 3rd hour, the IP address can be given to another person. So when the person comes back again, that IP address that was given to him or her will not be the same as the one that he left with. So that is one key thing you should be mindful of when you are setting up DHCP service. All right, so let's move on quickly. All right, so that's okay. So that is about it. So I think basically I've spoken about these requests. Now, as an example, so this is what is given. The DHCP, this is what it will provide to the computer that requests for an IP. So you get this, you get the subnet, you get the gateway, and you get the DNS. Now, because you've done data communication, what is the CIDR of this particular subnet? Anyone? Great. That is on a /24. Perfect. So on a /24, how many usable IPs do we, in fact, how many IPs exist in a /24? Two, 5, 4. What is the broadcast IP address? I'm sure you know what do you call it? How you're able to segment networks into subnets. So how many usable IPs do we have on a /24? How many usable IPs do we have on a /24? Yes, that is the 254, as Antoine said. So the question is, how many total IPs do we have on a /24? Great. So that is 256. So if the IP is 192.168.1 dot let's say 4, what is the broadcast IP and what is the broadcast IP and what is the network IP? But these are very key things. This thing I learned it somewhere in over 14 or 15 years ago. And I still remember some of these things. So it's, as a cybersecurity guy, you should know how to talk to it. So, all right, so the network is 192.168.0 and the broadcast is 192.168. Great. Jeffrey, you're right. Perfect. I'm happy you guys are giving that. And finally, in fact, in a quiz, I can ask you questions like this. For a /22, how many usable IPs exist? Listen to the question. For a /22, how many usable IPs exist on a /22? Anyone? On a /22, how many usable IPs exist can we have? On a /23 is 512. So plus or minus, you know what to do. On a /22, that's 23. On a /22, how many? All right, 1024 is the total number of IPs. But I want the usable IP. Great. All right, so Gertrude, that is it. And finally, on a /28, how many usable IPs? You tell me the total number of IPs and the number of usable IPs. On a /28. Oh. 14 usable. On a /28. Total is 16, usable is 14. Good. Lastly, on a /32. Yes, how many usable IPs do we have? On a /32, how many usable IPs? All right. Yeah, so that is 2 to the power 0. So we only have one usable IP. Indeed. So the subnet for S/22 is what? The subnet for S/32 is what? So you just count the number of bits for every octet and you get it. So the subnet for S/32 is what? For S/30. For S/28, I think it's 240, 255, 255, 255, 240. So for S/32, what will it be? What is the subnet? Great. If you're not using AI and you are telling me this, then I'm happy you know. All right, so these are good information coming from you guys. So on your screen, you can see we have the DNS server 8.8.8.8. We normally associated with Google. Domain name service server. Sometimes we say it's a tautology, whatever it is. So the gateway is the device through which you are going to get your internet access, or through which you'll be routed to a different network. Let me put it that way. So you'll be. So for instance, sometimes I go to a place, I try to play a devil's advocate. I connect to somebody's network if I have access to it, especially at the hotels. They give you the IP address, a password, you connect to it, and I'll check my network settings to see the gateway. Once I have access to the gateway, I'll go to the browser. I'll put in the gateway IP address, and it will give me a display of the access points or the router. And if most hotels, they are not serious, I think they just set it up without thinking of the repercussions of not changing passwords. And I'll try username admin, password admin, boom, and I'm in. So these things, so as a cybersecurity specialist, some of these things, when you set up some of these things, you have to make sure you hide the IP addresses. Sorry, you change the passwords of said devices so that you protect the network. All right. Sir, some of us are meeting our project supervisors at 8 p.m. Oh, please do. Please do. Sorry. Please do. And if you are my student here and your topic has still not been solidified, I've solidified some people. It means you are lacking because I'm meeting everybody again on Friday. Guys, I'll finish very soon. Let me just go through this quickly, then I'll leave you to go. So it's 8. Please, guys, you guys can go. Those that wanted to leave, you can leave. Let me finish this up quickly. Then I'll put up the video for you guys so you can continue. I want you to finish labs 1 and 2 and submit to me. All right, so quickly, DNS is just the same way. That is a domain name system, and it acts as an internet naming system. The way when I ask of Kelvin Eshen's phone number, although I know him by name, I don't know his phone number. So if I'm calling him, I have to now go and type Kelvin Eshen on my phone, and his phone number will pop up. And when I'm calling him, it is the phone number I'm calling, not the name Kelvin Eshen. So in the same way, the DNS also does the same thing. It resolves the domain names into IP addresses. And IP addresses are what the computer understands when they are converted to binary, zeros and ones. So that is what the domain name is. So for instance, google.com, if you type google.com, you will see google.com. If you type the IP address of google.com, you should still see google.com. Those of, okay, if I taught you web programming in first year, most times I will say local host in your browser, if you're running a server on your browser, is the same as saying 127.0.0.1. So that is the IP address of local host. So, but the DNS is able to resolve the name local host into an IP address, which is 127.0.0.1. So it's just the same way. So that is about domain names. And there are some security importance of the DHCP and DNS. And these are what have been outlined in here. For the section 3, data movement, these ones I asked you in class the first time I met you physically. You told me you had knowledge of the OSI model versus the TCP model. So I'm not going to go through this. I wanted to talk about it, but all of you are moving, and virtually it's just about the same thing. So I'll leave these ones to you. So packets and frames, all these ones. So now it gets to the lab 2. So I'll put up the slides. You can go through it, go onto the VLE, and complete the labs for me. So I'm going to put up the lab 1 and lab 2 as assignments here. So the deadlines will be given to you. Make sure you are submitted. You put it together and submit it. And I said Word document. This time around, I think it will be better to make it as a PDF. So please get it organized properly. This is an individual work. Get it organized properly and upload it before the stipulated deadline. Thank you very much, guys. I'm happy you gave me some time to complete lecture 2. So I'll see you guys again next week for lecture 3 and possibly 4. Have a good evening, guys.
Thank you, sir.
Right, Stephen. So let's call it an evening. I hope I recorded this. All right.